So I see that Clara is ready. Clara Armaroli from Italy. So
can you hear me? Can you hear me well?
I leave you share the screen.
Yes.
But
there is still a share screen of Mina.
Yeah,
Yes.
Let me check.
Okay.
Thank you, Mina.
Thank you so much. We are welcome.
Can you hear me?
Yeah.
I'm sharing my screen. Let me check if it works. It's a bit slow. I'm sorry. Can you see it?
Yeah, that's fine.
Okay,
we can
great.
start. Yeah.
Okay, so good morning, everyone, and thank you for this invitation. It's a pleasure to be here. And I am Clara Armaroli from the University School for Advanced Studies in Pavia, Italy. I am a coastal geomorphologist and I deal with coastal risk from flooding and erosion. I would like to thank and acknowledge all the members of this European project that I will present today that are part of the consortium of the project itself. So the presentation deals with in Horizon 2020 project, and it's the acronym of the project stands for a proof of concept for the implementation of a European Copernicus coastal flood awareness system. And the project is a research and innovation action that started in January last year and will end in December this year. It includes 8 partners from 5 European countries and is led by IUSS, and I'm the project coordinator. You can see the partners, the consortium of ECFAS, here in this slide. The project is financed under a call that is the Copernicus Evolution, research activities in support of the evolution of the Copernicus services. So it's a space call. It deals with the evolution of the Copernicus Emergency Management Service, and it will implement products and tools that could contribute to a fully integrated risk cycle monitoring service. So we deal with tools and products related with the preparedness phase, response, recovery, and also useful for prevention actions. So we are dealing with an evolution of the Copernicus service, and so we use Earth observation information and the information that are included in the Copernicus services that are relevant to this project, and namely the marine service, the emergency service, of course, the land service, and the climate change service. For those who are not familiar with the Copernicus Emergency Management Service, just a couple of words about the service. It deals with emergencies, of course, and it includes 2 main components. The early warning and monitoring components that includes the early warning and monitoring of different hazards, such as droughts, forest fires, and floods, river floods, and through the European Flood Awareness System, ECFAS. And the emergency service includes also information for emergency response and disaster risk management in the form of geospatial information that are provided to support emergency. Hello? That are provided to support emergency management activities in the aftermath of a disaster, and other mapping products that are provided to support prevention, preparedness, and response and recovery actions. The emergency service includes different hazards, as I said. So the early warning and monitoring includes river floods, but there is not in the system an early warning for coastal floods. So ECFAS deals with an application that is not yet realized in the emergency management service. While the mapping components that you see here are provided for different hazards, many kinds of hazards, such as earthquakes, landslides, tsunamis, and so forth. The ECFAS project, here you can see a concept framework of the project, and so we are integrating Earth observation and non-Earth observation products and datasets, and from the relevant services we use satellite images, namely the Sentinel images, and to develop the components of the system in relation to coastal floods. And the project includes two main components, because it builds on the framework of the emergency service that I just presented. So it includes a warning component in relation to hazards, so to coastal storms, and the information related to the potential flooding that can occur along the European coastlines, and the identification of thresholds of total water level that can trigger coastal flooding. Then we will provide different mapping products in relation to coastal areas, so to evaluate the impact in the aftermath of a storm event, and also to evaluate the impact of the storms on low-lying coast, on beaches, in terms of shoreline displacement and coastal erosion. And the final outcome of the project will be a roadmap of integration into the emergency service. And this roadmap will include not only how do we possibly integrate in the future this system in the emergency service, but also information about the strengths and limitations of the tools and products that are being implemented in the project. One important aspect is the involvement of users for co-design, co-development, and co-evaluation procedures. And in relation to the involvement of the users, this is a very important aspect of the project, because we involved users from all over Europe and beyond through different activities, through surveys, trainings, and workshops. And there are two external boards in the project that involve the Copernicus User Forum delegates of the countries that you see here: Italy, Greece, Spain, France, and Germany. And as a very important note, we have involved in the project the entrusted entities, so the entities that are responsible for the services that are relevant to this project. Given that we deal with coastal risk, we developed different products to evaluate the impact of storms, the potential impact of storms on coastal areas at the European level. Therefore, we have created a coastal exposure and vulnerability data set, collecting all the available information at pan-EU level in relation to coastal areas, and that are available in the Copernicus services, and also other publicly available data sets. And you can see here the number of layers and data sets that we have collected and that are relevant for the coastal areas all over Europe. One of the most important products that we are exploiting is the coastal zone layer that was developed by the Environment Agency, European Environment Agency, that is available in the land service of Copernicus, and that is specifically implemented to map the land use, land cover over coastal areas with a high level of, say, with a higher resolution with respect to the marine land cover, for example, and that is a 10-meter resolution. The majority of products of ECFAS will be made publicly available, so it will be possible to exploit our products and tools. This is an example of the coastal dataset that I just presented, that is available on an open repository, that is the Node repository. And at present, the access is restricted, but by the end of the project, most of our products and tools will be made open to everybody. Given that ECFAS deals with coastal issues and coastal storms, we have introduced a coast-targeted products. We wanted to evaluate which is the impact. We want to evaluate which is the impact of storms on low-lying coasts, on beaches, in the form of shoreline displacement in the aftermath of a storm event. Therefore, in the project, it was implemented a new semi-automatic tool to extract the shoreline position before and after a storm. The tool was developed by the Universitaria Politecnica de Valencia, that is a partner of ECFAS, and is named Shoreline Analysis and Extraction Tool site. This tool works on mid-resolution images, namely Sentinel-2, and optical images, Sentinel-2 and Landsat images. This tool will be used to add an information on erosion and taking into account the different morphosedimentary and hydrodynamic conditions all over Europe. And it was tested on different environments and taking into account also different tidal variations, so on micro, meso, and macro tidal environments. And this tool will be used to provide mapping products to stakeholders, coastal scientists, and all the users, the end users of our products, in order to evaluate which is the impact of the storms in terms of erosion. And also, this can be used to evaluate after a certain time from the storm, which can be the recovery of a coastal area after the erosion process, to help coastal managers to manage the coast. The system includes also the other components. These are products of the Copernicus Marine Service. We will provide up to 5-day forecasts of total water levels and wave parameters in order to forecast storms. And there is the identification of thresholds taking into account the variability of European seas and coasts, and that will be used to trigger the whole system and to issue the warnings. The system itself is being implemented. We are in the beginning, let's say, of the second year and last year of the project, and the activities that we are carrying out at present is the integration of all the products into the ECFAS system itself. It's important to underline that the models and tools developed in the project have been extensively tested in different test sites all over Europe, taking into account the variability of the coastlines of Europe, and taking into account also different storms with different intensities. And so we performed the calibration and validation of the flood model that is used in ECFAS to evaluate the potential impact of storms along European coastlines, to evaluate the, considering different combinations of waves and total water levels. And that is the LIS flood FP model that is already used in the European Flood Awareness System for river flooding, that is already implemented in the emergency service. And we have also verified an impact assessment method in order to evaluate which is the potential impact of storms that are forecasted along European coastlines. As mentioned before, we will provide different mapping products following the framework of the emergency service. So in relation to potential impacts, but also the mapping of the impacts that occur in the aftermath of a storm event, including the coastline variability in the form of shoreline displacement, so erosion impacts. This is a preview of how the ECFAS system will look like, and we are implementing the system, so the front end of the system in these months. It will be delivered by June, and it will include all the components, the warning and the mapping components. This is again an example of the front, let's say the front page, the main page of the warning component. And we will follow, of course, the framework of the emergency service, and especially for the warning part of the ECFAS, European Flood Awareness System for river flooding. So thank you for your attention. Just as a final note, I would like to underline that given the main, let's say, the women in geomorphology topic of this workshop, in the project there is a large involvement of women, and in fact 5 out of 7 work package leaders are women. There is almost 60% of the partners involved in working in the project are women. So I think this is a really important aspect to take into account. And if you want to have additional information, you can send me an email or visit our website. Thank you very much for your attention.
Thank you very much, Clara, for your very interesting presentation. Now the floor is open to question to Clara. So
hello, Clara. I have a question for you. I have a limited knowledge of this field, but I'd like to ask you about the topographic data that go into this system. So what, I may have missed it, you may have said, but what is the source of the topographic data, and does this cause any problems?
Actually, this is a very important aspect. As I mentioned, the system works at pan-EU level, so we have to exploit pan-EU datasets. And we are using the digital elevation model available at the European level with the meters resolution. And let's say this is the only pan-EU dataset that you can exploit. And
did we lose her? Or was it just me that lost her?
Can you hear me?
Ah, good, yes.
Okay, sorry, I was trying to interrupt the sharing of the screen, so there was a bit of was stuck. So the digital elevation model is an issue, in fact, given that it has a vertical precision of meters. So for the flood modeling, etc., this is an issue. But of course, given that this is a pan-EU system, we cannot use more detailed and more precise local data. And so this is, in fact, is a limitation. And there is a continuous effort to improve the datasets available at EU level in order to get more accurate and with higher resolution datasets in order to improve the already available products. But this can be a future of ECFAS for improvement.
Okay, thank you very much.
I think that there is another question. Angela?
Yes, it's a very quick question. And first of all, thank you, Clara, for your presentation, and your project is very, very interesting. During the presentation, you mentioned that you have used total water level and wave parameters for your simulation, for your analysis. And my question is if these data are extracted from the Copernicus data store platform, or are evaluated case by case in your study areas?
The total water level includes different components. It includes, of course, tides and the wave contribution in terms of wave setup. And it's a product of Siemens, is a product of Copernicus. And in fact, Mercator Ocean International is the entity responsible for the marine service of Copernicus and is involved in the project. And they have developed new products in relation to these aspects for coastal areas in terms of total water level forecast. So it's a product of Copernicus.
A product of Copernicus that is available on the Copernicus platform.
It is available. It will be available through our system. So it will be possible to download the information through our system, but it's implemented also in the marine service, or it will be soon.
Okay. Thank you, and congratulations for the project.
Thank you very much.
Well, thank you very much. I think that now we can pass on to the next and last presentation of this session 1.